Right, Chapter 4, Section 4. In this section, we're going to learn how to build quadratic models from verbal descriptions and how to build quadratic models from data. All right, so let's look at the first topics. Build quadratic models from verbal description. This all the signs and operators is kind of dropped. So that is the original function, okay? So the verbal description you can check on the textbook is talk about R of P. This is a revenue function, okay? The independent variable is the P, which stands for price of per calculator, okay? The selling price of per calculator. So the revenue of P equals negative 150 P squared plus 21,000 P. And we want to, graph this function and then find a vertex. All right, so given the quadratic function, we need to identify A, B, C coefficient, right? So A equals negative 150, right? Numerical value of x second power term. B equals 21,000, numerical value of the independent variable first terms, right? First power term. And C, we don't have the constant term, so C equal to 0. All right. And then find a vertex. Vertex denote as HK. H is x coordinates of vertex. K is the y coordinates of vertex. Okay, so let's find the x coordinates. H equals negative b over 2a, right? That's the formula. And then we plug it in. That's negative 21,000 divided by 2 times a. A equals negative 150. So if you notice, negative cancel out, right? Become a positive. So we got a 21,000 divided by 300. So that's give us 70. All right, and then y coordinates k, we need to evaluate r of 70, right? Evaluate function when p equals 70. So that's given us negative 150 times p squared, p equals 70. So that's 70 squared plus 21,000 times 70. Okay, you put this expression into the calculator, you get 735,000. Okay, so that is the vertex. All right, and then in order to graph this quadratic function, we need to find, x and y intercept, right? So y-intercept is very easy to find. Y-intercept, right? Y-intercept is very easy to find, which is 0c, where c equal to 0, so that's 0, 0. Okay, so that's the y-intercept, and actually it's also the x-intercept. All right, and then we know axis of symmetry is x equals negative b over 2a, right? So it's a vertical line passing through the vertex, so the line equation is x equals 70. Okay, that's the axis of symmetry. And then based on the symmetrical property, here is a 0, and then here is 70, right? And then symmetrical, that means the other will be also the same distance, right? Which is a 70. So 70 plus another 70 should be 140. Okay. So symmetrical point of the y-intercept is 140, 0. And actually these two are just happen to be x-intercept as well. Okay, so let's try to find x-intercept. All right, I need a little bit more space. Let me see, x-intercept. X-intercept, we need to let the y be 0, right? So r of p equals 0 equals negative 150 p squared plus 21,000 p, right? We need to solve this quadratic equation. And then if we both sides multiply by negative 1, or just move these two terms to the left-hand side, we got 150p squared minus 21,000p equals 0, right? And then we factor 150 out. Okay, 150p out, we got p minus 140 equals 0. So that's tell us zero factor property, right? Either p equals 0 or p equals 140, right? P minus 140 equals 0. We can easily solve p equals 140. So two x-intercept, one is 0, 0, the other one is 140 and 0. That's exactly matching the y-intercept, and additional points symmetrical with y-intercept. Okay, so that's these 2 points actually are the two x-intercepts. Okay, and then we can use these 3 points to graph parabola. And the leading coefficient a equals negative 150 less than 0, so we know parabola open downward. Okay, so that's how we got this graph. And then the next question, this is plus. Same quadratic function, okay, r of p equals negative 150p squared plus 21,000p. And then if we know the revenue r equals 675,000 and ask us to find the calculator's price, okay, which is a p. Okay, we find what price of the calculator we can make the revenue equals 675,000. So from the graph point of view, okay, we draw a horizontal line. Okay, this is y equals 675,000. Okay, and then we can clearly see this line intersect with the parabola 2 times. Okay, so we're trying to find these 2 intercepts. Okay, so solving this equation, negative 150p squared plus 21,000p equals 665,000, right? Just replace r by this given value, right? And then we move all the term to one side. So let's move both the term to the right hand side. Okay, so we have 150p squared minus 21,000p plus 675,000 equals 0. Okay, we're trying to solve this equation. And then we can cancel coefficient 150. Okay, all the term divided by 150. And then we got p squared minus 21,000 divided by 150, we have 140. 140p plus 675,000 divided by 150, I got 4,500 equals 0. And then this quadratic function, we can easily find a factor form, right? 50 times 90 equals 4,500, and then 50 plus 90 equals 140. But the sign is negative, so both 50 and 90 are negative. So we factor as p minus 50 times p minus 90 equals 0. And then we can easily solve p equals 50 or p equals 90. Okay, so in other words, when p equals 50, and then the revenue equals 675,000, and also when p equals $90 per calculator, and then the revenue equals 675,000. So that is just 2 points on the graph. Okay, 50, 675,000, 90, 675,000. Okay, so we solve this word problem.